There's an angular momentum of a 24 kilogram ball rotating at the end of a thin string, circular radius, blank angular speed. Okay, so that one you have like a thin. So this is basically the string's pretty much massless. So like a rod would be if the mass was like uniform throughout the whole thing, right?
Mm-hmm.
So if the mass was evenly distributed. But since most of the mass is to the outside, when it spins, it's going to sort of make this shape.
Yeah.
So you want to find one that gives a moment of inertia that has all the mass on the outside and none of it on the inside.
Oh.
Yeah.
Okay.
Mm-hmm.
So basically like a hoop.
Yeah, like a hoop exactly, which would be
B right
yeah,
here.
and more
Okay.
squared.
Oh.
Exactly.
1 times. Oh. Okay, so it's just its mass. Yeah, maybe answer. Oh.
So it's an angular momentum
Times the
of
angular velocity.
yeah, so it'd be 24 times 1 squared, so 0.240 times that, yeah, 10.2.
Is that kilograms times meters over second squared?
Kilograms. Let's see. What is? Yeah, it's kilograms times meters squared times radius. Just look it up. We're looking at angular momentum.
Yeah.
No. Kilograms times meters squared per second.
Oh.
Yeah.
Awesome. Okay, now this one.
I think this might be it, but I'm not.
We're just trying to see how you got to it.
Okay, so I'll try to explain it. Okay, so we know that this is true, right?
Yeah.
So I set it up. So what I did was I just wrote out like so you have the kinetic energy initial, which is 1/2 IT initial squared, right?
Mm-hmm.
Equals our final 1/2 IT plus IR. And then I substituted this in, angular final in. Squared it, right? So we'll square each term. So, and then we have like this plus. So I'm trying to find out what is the difference between these two? So like what is this X? Like what is the friction basically on it?
Okay.
So I just take out common terms, so 1/2, get rid of that. We have this squared initial, get rid of that, get rid of this guy. So we just have him left. Well, we can simplify this. So we just have that left. And then this can take away one of these, basically.
Mm-hmm.
So this is what the difference is between kinetic energy final and kinetic energy initial. So if that's true, we look at this equation, and our final should be our initial subtracted from that.
Yeah.
I don't know if that's right, that's just kind of what I'm guessing. It's like my hunch.
Okay. Well, looks right. Well,
I don't know.
the steps you went to, you got to it.
It's kind of confusing. You could try. I don't know if it's gonna work. To be honest, I'm not like that.
No worries.
I'm not that sure about it, but
I would have just gotten frustrated and then just typed in wrong answers on purpose, just to see what the answer was.
just to see what it. Well, we'll see. I don't even know.
No, it wasn't.
Yeah, it was a stinking one.
Yeah, really.
Yeah, so that's right.
Okay. Minus.
Oh, that should be the lowercase r, I think it is.
I'm not signed up,
IT, if you want. What does it say? I wonder.
Say something useless.
Let's see, find the initial rotational kinetic energy. Okay. Yeah, I know, yeah, because I know what those are, I just don't know how to.
Put it all together.
Yeah. Use the relationship between I and from the answer to the first part of this problem to express kf in terms of ki. Then use the equation relating ki. Yeah, to express kf in terms of ki. Hold on, I don't get it. Use the relationship between from the answer
So it's the same.
to the first part of this problem to express kf in terms of ki. Okay, yeah, we did that, right? Well, I kind of canceled it out. So that's what this is. Okay, that's what that is. In terms of then use the equation relating ki initial and k and angular velocity initial to express kf in terms of ki. Okay, so this is kf. And we have ki. 1/2 IT equation relating ki to express kf in terms of ki. Oh, I get what it means. It wants us to solve for this. And then plug it in here. So we'll have oops. Like that. Right?
Okay. Yeah.
You could type these in to make sure that those are right. But then, and I think that's how we solve for it, because we multiply by 2, divide by IT, square root, plug that into there, to solve for kf in terms of ki.
There's no way to simplify that even more.
Probably, but
Oh, shoot. Okay.
actually, let's do this. So square each term, so, and this is actually this whole thing is square rooted. So so we square root this whole term, that just becomes 2ki it times it squared, which cancels that bottom one, right?
Yeah.
So you just get 2ki times it divided by ir plus irt squared. So that cancels this and that. So you get 1/2 times 2ki it divided by ir plus it. That can cancel.
IT or
One of them's it, one of them's ir.
Oh.
it divided by ir plus it.
Okay then.
Maybe? Does that look right, sort of?
Yeah.
Like, did that make
How-
sense?
how you
Did my
guys
math
look
make
right?
sense?
Yeah. Okay.
Good
so
try.
that's good, or-
I hope that's right, man. This is
If that's not, I'm just like, oh, screw it.
This is a ridiculous problem.
Okay, so. Okay. Yes.
Sweet, man.
Oh my god.
That is a silly problem.